The next concept you guys are learning is called heat transfer. See, when we talk about heat transfer, we all know that there are three types. It's a very simple thing: conduction, convection, radiation. So these are the three types of transfer of heat. When I say transfer of heat, it is transfer of heat energy. Correct? Now, we all have learned these things before. See, conduction is, it goes by touch. Correct? When you have a hot object, if you touch it, it's basically heat is transferred. Or convection is water boiling. That's convection. Radiation is through sun and everything, isn't it? So for convection and radiation, you don't have to actually touch, still you get to feel the heat. Now let's try to understand what is conduction, convection and radiation in detail, that is the modes of heat transfer. We'll start with conduction. See, when we talk about conduction, now a very simple example for this is, suppose say a metal rod is quite hot. If you touch it, it's going to, the heat is going to get transferred. Now, what you need to understand here is that because the two objects are in contact with each other, that is why the heat is being transferred. In the sense, it is a mode of transfer of heat energy where the particles actually they transfer the heat energy, but they do not move. That means the heat, whatever that particle, the molecule or particle which has that heat energy, it's not going to move from place to place. It will be there only. But the heat energy is transferred. Like I told, a metal rod is a beautiful example where you can understand how conduction works. Okay, like take an example of a spoon in your houses. Keep it near a flame or something. After a point of time, the entire spoon becomes very hot. See, this is an example for conduction, how the heat and the heat energy is transferring. All right, conduction, one method. The second method is convection. See here, convection generally occurs in gases and in liquids, or we can, in general, we can say fluids. Okay. Now, what is convection? It is a mode of transfer where the object which is at higher temperature, or you can say a particle which is at a higher temperature, it actually moves from place to place. Unlike in conduction, where the particle is stationary, but only the heat energy is transferred. In convection, the particle actually moves. When the particle moves, heat energy is transferred. Clear? This is a very simple, explanation of what is convection. Now, a best example for this is boiling water. See, when you keep water to boil, as you start giving heat from the bottom particles, they heat up, they become lighter. So they move up. The heavier top particles, they come down. So what's happening here? So the lighter particles are actually moving up, coming down, moving up, coming down. So this is what we call as convection. Okay, so conduction is done, convection. Now in convection, there are two types. Okay, one is called as natural convection, one is forced convection. Now, when we talk about natural one, what happens in nature? Now, in this, what you can understand is that, have you noticed, during evening times and all, if you go near the sea or a beach or something, you get that breeze, correct? Now, this happens because of the convection. In the sense, what happens during daytime, the land is going to heat up quite fast compared to water. Okay, and since land quickly heats up, the warm air from the land, it rises up and it goes towards the sea, and then the sea, whatever you have, that comes towards the land. So as you can see in the figure here. Okay, now here, don't you think this is the rotation of the air? Air is a fluid, right? That is convection. Convection mode of transfer of heat. During night time, what happens? Land cools down faster compared to water. Since land is cooling down faster, the temperature drops. Again, there is a convection of heat here. So look at the figure here. You will be able to understand what is what here. Correct? So see, this is a natural convection, or you can say natural mode of transfer of heat. Okay. And not only that, now we have a very important thing called as a trade wind. See, trade wind occurs at a particular altitude in the atmosphere. What happens is, see, equator is constantly, it is exposed to the sunlight, unlike the polar region, isn't it? Now, because of that reason, the air within that equatorial region is going to, it's going to get warmed up quite quickly, and then it's going to start rising upwards. As it rises upwards, it moves towards the polar region. Now, polar region, the movement of air is very, very slow because it's very cold up there. So this warm air is going to move towards the polar region, and the dense cold air from the polar region, they will start to come towards the equator. Okay. Now, this trade wind, it generally happens from northeast direction towards the equator. Okay, from northeast towards the equator. Now here the rotation of earth and everything matters a lot, changing the direction of the conventional current here. But still, the logic is this one. Not more than logic, it's more like how the natural phenomenon occurs. The warm air from the equator rises up and it's going to come towards the polar region, and the cool air from the polar region is going to come towards the equator. So it forms a convection here. So there is a air convection in this atmospherical region, or in this atmosphere you can call. The speeds of these wind can go up to 1600 kilometer per hour, which is quite a lot. Okay, and then it doesn't come all the way till the equator, because before it comes to the equator, it's going to rise up the temperature. So it's generally, it will be like 30 degree north, 30 degree north, somewhere close to that. All right, this is more like the latitude, what we can say. And these winds, we call them as trade winds. Okay, these are called as trade winds. See, this is also a naturally occurring phenomenon. Now, these are natural convection mode of transfer of heat. There is a forced way of transfer of heat also. Okay, now not just heat, I would say, movement. Okay, like we can talk about the pumps, air pumps, whatever we have, they like vacuum pumps and all these things are there. No? So that is an example. All right, or the air coolant system in an engine. That's also an example for forced convection way of transfer. So there are multiple examples. Clear? Now this is the second one. The third mode of transfer is called radiation. Now, radiation is what? Here also, it's a mode of transfer of heat where the source and whatever the object, they're no longer, they're not even in contact. And also, in radiation, that medium, whatever we have in between, that is also not really important. Okay. Now, best example is sunlight. So, sun is so far away compared to Earth, correct? And see the heat what we have from the sun. Now, this is what we call as radiation. All right. Now, remember, for conduction, for convection, medium is very important. Without the medium, there is no conduction, there is no convection. But for radiation, the medium is not really necessary. It's not that if medium exists, it won't happen, nothing like that. Even if you have medium, even if you don't have medium, the radiation is going to come and hit the object. That means the energy, whatever the body dissipates, it's called as the radiant energy. Okay, the heat dissipated by the body because of the radiation is called as the radiant energy. Now, generally from sun, whatever the heat we get, that's because of the infrared rays, infrared and microwaves. And they travel with the speed of light, 3 into 10 power 8 meter per second. And in between, it's all vacuum, correct? That means no medium is actually required for these heat to transfer to the earth. Clear? This is what we call as the radiation. So these are the three types of heat transfer. Conduction, which happens in solids and by contact. Convection, which generally happens in fluids. Again, for these two, you need to have a medium. The third one is radiation, where you don't need to have a medium, still the heat will be transferred. So these are the three types of heat transfer in objects.